Welcome to Study Loop.
Hi, in the given problem, this is a blood vessel in which the ions are moving towards right with a speed v. We can consider one segment of this vessel whose length will be equal to the diameter of the vessel, means d. The magnetic field here in this region is perpendicular to the plane of paper and directed into it like this. The magnitude of magnetic field is B, which is directed into the plane of paper. Speed of the ions is V towards right. So these ions, if we talk about the negative ions will experience a magnetic Lorentz force. Magnetic Lorentz force experienced by the negative ions will be given by Q, V cross B, where Q is the negative charge. So we can put a negative sign here. And then if we apply right hand screw rule over this cross product of velocity with the magnetic field, and the magnetic field is acting inward, so we can draw a magnetic field line here like this. So when we apply right hand screw rule, V cross B is counterclockwise. So the direction of V cross B is upward, but due to this negative sign, the overall direction of this magnetic Lorentz force is downward. In the plane of paper, downward means all the negative charge will accumulate at the lower end of this segment here. So comparatively, this lower segment will acquire a negative potential, and hence there will be an electric field developed because this upper segment will acquire a positive potential. So an electric field will set up here, let it be E. So after some time, what will happen? All these negative charge will start experiencing, this was the magnetic Lorentz force, so the electrons will start experiencing an electrostatic force. Not the electrons, means the negative ions will start experiencing a force in upward direction. So we can say after some time, these negative ions will start experiencing an electrostatic force upward from negative to positive. So that will be given by Fe is equal to minus Q E. So in equilibrium, when these two forces will become equal, now no further ions will move up or down. So in that case, we can say Fe will become equal to Fb, or we can say this minus QE is equal to minus QV cross B, or minus QE in scalar form, this will become equal to minus QVB sine 90. As V and B are perpendicular to each other, so it will become minus QVB. Here, negative sign and the charge Q will be cancelled. So this electric field comes out to be equal to V into B. But electric field can be given as the potential gradient, where we can consider the EMF or potential difference induced across this segment to be epsilon. So it can be given as potential gradient means EMF per unit length, which was actually the diameter of this blood vessel. So it will be D. So when we put this value here, we will get epsilon by D is equal to VB. So finally, the expression for this EMF induced comes out to be VBD. This is the answer for the first part of the problem. Now, in the second part of the problem, we have to find the required magnetic field to give these ions a speed of 15 centimeter per second across the given blood vessel. So the speed is 15 centimeter per second, or it comes out to be 0.15 meter per second. The diameter of this blood vessel is 5.0 millimeter, or we can say this is 5.0 into 10 raised to the power minus 3 meter. EMF which we require to be produced is 1.0 millivolt, or we can say this is 1.0 into 10 raised to the power minus 3 volt. So using the same expression which we proved in the first part, the expression for magnetic field comes out to be epsilon divided by Vd. So when we put these values for epsilon, this is 1.0 into 10 raised to the power minus 3 volt. For speed, this is 0.15 meter per second, and for D, this is 5.0 into 10 raised to the power minus 3. So here this is cancelled. So the magnetic field finally comes out to be 1.33 Tesla. So this much magnetic field is required in order to create 1.0 millivolt of potential difference. Now we have to obtain an expression for the volumetric flow rate of the blood through the vessel. So we know the expression for the volumetric flow rate. The relation between the volumetric flow rate and the velocity of a flow through a pipe is given as the product of velocity means speed with the area of cross section of that pipe. So here it will be given as V multiplied by area, which is the area of a circular cross section, which is pi into r square, and r is nothing but half of the diameter. So it comes out to be V pi d square by 4. Now we know the expression for EMF, which was VBD. So using the expression for V, it becomes epsilon divided by BD. So here we get this volumetric flow rate as pi d square divided by 4 multiplied by epsilon divided by B into D. Here this D is cancelled. So finally the volumetric flow rate comes out to be pi times epsilon into D divided by 4 times of magnetic field B. Thank you.